Hi guys, welcome back. Now we are going to look at the next step. In the next step, we are going to initialize the Softdevice. For that, we need to include some of the files because it's a template project and it has already included S140 for us, which is used with the nRF52840, S132 for nRF52832. So the Softdevice is already included and all the files are already added here in the configuration, so we don't need to do anything. But I will go through all of the stuff so that you know what do we need to include and how it's included and how we modify the stuff. So first of all, to use the Softdevice, we need to include some of the header files. So I'm just going to include them. The first one is nRF/SDH. Okay guys, now we have included some of the header files that are needed for the Softdevice. The next thing we need to see is whether the Softdevice is enabled or not. So in the SDK config.h you have to check. So let's go there using CMSIS configuration wizard, and here you see nRF Softdevice, and it should be enabled, otherwise the Softdevice will not work. Because it's a template project, it has already configured everything, but these configurations are on default. So if you want to change some configuration for some specific applications, you can check around the configurations and you can change them. So make sure it's enabled, and here nRF/SDH enabled. Here we will see some other stuff as well, like clock configuration. So here is something really important for the Softdevice. We have to make sure our Softdevice is taking the input from the right clock source. For example, if we are not using any external clock source, then the microcontroller is going to use internal clock source, and internal clock source has its own accuracy. For example, if you are using the internal clock source because your board does not have it, the external clock source, then you can use 500 ppm for the internal clock source. But the external clock source is really accurate, so we will use this 20 ppm. I already told you everything is already configured for us. Here it's using XTAL, which means it's using external clock source. So on your boards, if you are using the development boards, then it's already installed on the development boards, so you don't need to worry about this. This is for the experienced programmers. For the beginners, you don't need to worry about this. You just need to know that we are using the external clock source for the low frequency clock, which is 32.768 kilohertz. So we will be using that frequency for the low frequency clock source, and make sure it's enabled and everything is good to go here. The next thing we need to check is whether our Softdevice is included or not. So as I have already mentioned again and again, that we are using our template project, which has already included everything for us, so we don't need to worry about this stuff. But let's see where our Softdevice is placed and how we connect it with our application program. So right click on your project, go to options, and let me maximize it. Okay, so here first of all you have to change the configurations to common, because in the common you will get the basic configuration. So here if you go into the linker, and here you will see the memory segments for the RAM, and here is the placement, flash placement section. This is also important. I will cover it after we finish this basic application, and how we know what are these configurations. I will create a special tutorial on this, but for now we just need to know that these are the basics of placing the Softdevice in the memory, flash memory, and reserving some space, RAM space for the Softdevice. Later on we will see how we can configure it, and in the previous, if you don't know what is a Softdevice, and just see my previous tutorial. In that I have covered some basics of Softdevice. So here the Softdevice RAM and flash configurations are already configured for us, and here is one more thing. If we go to loader, and in the loader here you can see the Softdevice has been included by this link. So this is the Softdevice that will be loaded into our controller. Because I'm using nRF5 2840 and my board is PCA10056, so my Softdevice is basically S140. If you are using nRF5 2832, then your Softdevice will be 132. Make sure you don't interchange these Softdevices, otherwise suddenly you will receive some unknown errors during the operation of these devices. This is the Softdevice. It's already compiled. It's .hex format, and it's already compiled, so everything is loaded. We don't need to change anything here. I'm just showing it to you so you know where is the everything and how is everything configured. The best thing about Sagar Embedded Studio is that everything is pre-configured, and all the projects can be directly loaded, so we don't need to worry about a lot of stuff. So for beginners it's really good, and everything is on place, so we will just click on OK. So the Softdevice is configured and everything is there. We have included the header files which are going to give us some functions that can communicate with this .hex Softdevice, pre-compiled Softdevice. So basically now we will use our program to communicate with it. So now the first thing to do is we have to initialize the Softdevice. So I will say let's name it as step 4. So in the step 4 we will just initialize the BLE stack. Basically we are initializing the Softdevice. Let's name this function as BLE stack in it. So first of all we need an error code variable. So for that I'm just going to create an error code variable. Now there are some other stuff that we need to do before we enable it. So first of all we have to send a request, the enable request to the Softdevice. For that we will use a simple function which is going to send a request to enable the Softdevice. Basically we are just sending a request, so it's going to check with the Softdevice that everything is configured, so that everything is good to go, and it can start the Softdevice. In order to enable the Softdevice we need to initialize it into the RAM. So for that we will use a special function for this, which is going to configure everything to default settings for the Softdevice. So for that here we have to give a simple constant. For that we will have to define this constant here. So let's define this constant. Here we are just creating a simple tag, and the tag has been given the value as 1, and next thing we need to pass it is the RAM start, so which is basically here we are just giving it as a 0. And the next thing is we have to use the same function here as well, so that if something goes wrong during these configurations, then we know what happened. The next thing we need to do is we have to enable the Softdevice now. First we have sent the request, and then we have configured the default settings, and now we have to enable it. So if everything goes well, it will be enabled. So now we will just use the enable function, and here we will just pass it the RAM start address, and again we will use the same function, app error check, for this as well. If something goes wrong, it is going to give an error, and it will be printed on the log. Now the main thing comes here. After we enable the Softdevice, how our controller communicates with this stack. The next thing we need to do is we have to register the BLE event callback function, and for that we have to put an observer. The observer is just basically going to observe all the BLE events, and it's going to pass these events to us, and we will handle these events in the event handler function. For that we have to create an event handler first, so let's create an event handler right above this code. So let me say it's a step 4.1. So for the BLE event handler, let's start by giving it a name. And it will pass us the pointer to the events, and then we will see these events. We will check these events, and if these events are needed to be processed by this application, then we will process these events. Some are really important to process, for example the connection and disconnection events, so we know that if our device is connected or it has been disconnected. So this is the BLE event handler, and now we will register it in the function here in the BLE stack init. So for this we will use a special function, and here we have to set the priority of this event handler. For that, let's create, which is going to define this interrupt priority. And let's say the priority for this is 3. And for most of the cases you don't need to change it. 3 is the best priority for the BLE events. Everything is here. So the first thing we need to pass to this function is the name. So let's name it as BLE observer. The second thing we need to pass it is the interrupt priority. For that I will just pass this observer priority that we created. The next one is BLE event handler, and the last one is just a parameter, and we will just pass it null because we are not passing any pointer to this, and that's it. And the BLE stack init is completed. Now let's see the BLE event handler. So here in the event handler we are going to handle the events. So first let's create a simple error code variable, and let's give it a value as nRF success. So it just shows that there is no error. The next thing is we have to use a switch statement, and we will observe which events have been generated, and then we will perform some specific stuff on those events. The first case is the second case would be the third case can be this one. So guys, there can be many cases here, and I'm not going to cover all of these cases for now because it's just a beginner tutorial. In future tutorials we will see more of the cases, and because they are related to application specific stuff. So basically these 3 cases are enough for our basic application. The first case is the BLE gap event disconnected, and in this case we will just print out a simple message that our device has been disconnected. The next case is BLE gap event connected, and for this case we have some extra stuff. It is a little complicated for the beginners at first. The thing is, we need to do some extra things, and I will cover them in the same code but in the future tutorials. But now here, for the sake of simplicity, I will not explain a lot of stuff about them. We will just go through smoothly from here, and in the next tutorials we will see how we can do that. So for the BLE gap event connected, first we will put a message here. Let's say the device is connected, and now we have to show some state to the user. For that we will use simply we are going to use the both support package, and we will just use a simple indication state. For that we will just call a simple function. So this state will be shown by the LED, and BSP indicate connected will show the LED will remain turned on once our device is connected with some other BLE device. So for this, the next thing is we have to use the error check function. And now something important comes here. The device which we are going to connect, we have to save its connection handle, because if we don't know the address, then we won't be able to write the stuff on that special device. So in order to write, we need a connection handle. So first of all, we will create a handle here. So in order to create a handle, we need to use, let's name it as mcon handle, and first let's give it a default value of invalid connection handle, so that if the connection handle is not valid, then our device will be handling the error. Now the connection handle has been created. We will use this variable because this will save the connection handle for the newly connected devices. There is one more thing. We don't write the data directly, so for that we have a special queued writer module, and the queued writer will basically write the stuff. So for that we have to define it. So let's define that. In order to use the queued writer module, we have to include its header file. Now its header file has been added. Now we will create an instance of queued writer. We have to pass this instance along with the connection handle so that our device can easily communicate. Let's create a queued writer instance. There are two defines. One is QWRS and one is QWR. If we are connecting with more than one devices, then we need to use QWRS. If we are connecting with just a single device, then QWR is okay. So here I'm just using one device. I'm just gonna use one device, so I'm just using this, and let's name it as mQWR. Okay, now the instance of queued writer is created and the connection handle is created. Now we need to do something here in this function, BLE gap event connected. Now we have to assign the connection handle to the queued writer. Before that, we need to assign a value to connection handle. So since it's connected with a device, so we will take this handle address and save it into our mcon handle. So for that, and this is the handle that we will pass it, and now the handle has been assigned a value. Now we will assign it to the queued writer, so everything is good to go. And we have to just pass it the instance and the connection handle, the instance of queued writer. Now let's see the third case. Sometimes the device which is communicating with our device might want to use the faster communication rate. For example, our device is set to 1 MB PHY and it wants to use 2 MB, so it wants to update it. So it's going to send this update request, and in the update request we can handle it, and we can update it according to the device which is communicating with our device. So for example, if my phone wants to communicate at 2 MB and my PHY is set to 1 MB, and I have set it, if the device supports 2 MB, we can communicate in 2 MB. We will just use a simple code to update these values automatically. For that, let's write this simple code. First, let's send a simple message on the debug. Now let's create a structure. Okay, now we have created a simple structure, and it's going to automatically assign these values so that we don't have to take care of it. So whenever it's going to receive this event, it's going to assign them these auto update values. So in the end, we have to use a function. This is just a structure. Now we have to pass it to a function. Now we have passed the address of the structure. Now we just need to use a simple app error check, and it's good to go. So guys, for this this was the next step. In this step, we just have requested, and then we have configured our BLE stack and enabled it. Enabled our Softdevice, and in the end we have connected it to an observer which has an event handler. So whenever an event is occurred, it's going to be received, and in this event I'm just using some connection and disconnection and update request events, and I'm just using some code to let the user know, like, if our device is disconnected. If it's connected, then the LED will turn on, and also I'm assigning it to the queued writer, so that I'm assigning it to a connection handle and a queued writer. These concepts might be foreign to the new users, but soon these concepts won't be foreign to you. For the beginners, I'm talking about this. So for soon these concepts won't be foreign to you. And here we have the third case. In this case, if any update PHY update request comes, the device handles it, and everything is set here. These events are enough for our basic application, the minimum BLE code application, and this is the base project. So these events are enough, and later in the future, if we want to add more events, we want to handle more types of stuff, we can handle them. For now, these are enough. We will see the next step in the next tutorial. Thank you very much for watching. See you in the next video.